Okay, here we are. This is a first, Jono. We're on the road with the podcast. I didn't think we'd ever take this thing on the road. When we got the neon sign, I didn't think that would come out of a studio, but here we are on the road. We are at the Higher Education Technology Agenda, Theta, in Perth. We have a stand here. We obviously have the podcast, mobile studio set up. We've been on stage. We've been talking about the launch of Cordet Cloud, which is our latest and greatest thing. We're not here to flog that necessarily. I will just say a little thing about it. Obviously, it's the bringing together of different platforms. It helps with Research Cloud. There's high performance compute. There's Azure Local. There's all sorts of things in there. Ease of transaction and contracting through Cordet. That's what we're all about. That's all I'm going to say on that. More importantly, we're here with a very special guest. How about you introduce our guest?
I can't wait to introduce our guest, Luc Betbeder. Luc is a person in the industry who's doing some amazing stuff with cloud and research data and, obviously AI.
Certainly.
And so I'm pretty excited about today's conversation. But before we hand to Luc, a little bit of a bio.
Yep.
Luc is a nationally recognized subject matter expert in high performance research computing, research data practices, and shared research infrastructure services. He is currently Vice President of AeRO, Australia's... President,
Hey,
there we go. Australia's, congratulations. Australia's eResearch organisation and co-chair of the eResearch Australasian Peak Annual Conference. He is an adjunct senior lecturer at UNSW Faculty of Medicine Centre for Big Data and has been a visiting scientist with the Data61 Visual Analytics team in Australia's National Science Agency, CSIRO. He has held director-level roles for 15 years in higher ed, ICT and eResearch. Luc is currently the Executive Director, Research Technology Services at UNSW, a shared services function that he established. Recently, Luc has been working with colleagues to regularly count how many high-performance computing cores and research data there are in Australia and New Zealand. That's a bit of a mouthful, some serious achievement.
Sorry about that.
Okay.
Fantastic, and welcome, Luc.
Very happy to be here. Thanks for the invite.
Pleasure.
No, it's good fun.
Luc, there are so many places we can go with this conversation. I think perhaps a good place to start would be, tell us a bit about what you're up to.
Yeah, like it said in the bio, I've got lots of fun parts of the roles at the moment. So nationally, we're involved in some of the conversations around the National Digital Research Infrastructure Strategy and roadmaps. So what kind of research infrastructure we should have nationally. And that's important to me from a workforce perspective. So I'm mostly here speaking with my, what we say, AeRO hat on as president of AeRO, which is our Australian eResearch organisation. So teams like mine that are at UNSW that are doing digital research infrastructure work for organisations in Australia, whether that's inside CSIRO, inside a uni, inside, say, the ARDC or National Infrastructure for HPC, NCI in Canberra or PAWSI, all of those folks who do support research from an infrastructure perspective, they're the kind of people that I like to run events like Theta for. So we run the eResearch conference for our workforce, for our community, and that's passion for me to invest into our workforce, to have places where we can tell them about the latest and greatest and start to benchmark off each other and share a bit of information. So coming to conferences is something that I like to do. I like to bring my team along to conferences. I like to share what we're doing in forums. So doing a podcast to share a little bit about what we're doing is another way of being engaged with the community. So thanks for the invite. I really appreciate it.
No, you're welcome.
You're very welcome. And let's see. So we know that in the conversations that we've been having with the various leaders around Australia around generative AI, there's a lot of talk around lived experience and that rolling your sleeves up and just exploring this technology space really helps to figure out how to get better outcomes. So can you give us some perspective on what are some of the obstacles and what are some of the lessons in how to embrace this stuff properly, and what are the kind of things that you're imparting upon your members in this space?
Oh, it's a good intro. In a way, the first thing that I thought about it takes me back to one of the things that I started in one of my very early projects, very early fields. So I started as a researcher at UNSW, spying on old people living at homes by themselves. So our assumption back in the day in
Did they know about it?
Yeah, with full ethical permission and
Right.
full ethical, approval.
Yep.
We wired up people's homes, living at home by themselves. And I don't know if you knew the television show towards 2000 or Beyond 2000. We actually were on an episode of Beyond 2000.
I used to love that show.
And
Yeah,
so,
me too.
you know, we had old PCs with old donated modems dialing back to the university every night. I think I contributed, or I was one of the co-creators of Australia, or maybe the world's first toilet flush sensor that dialed information back to a central aggregation point. So, nothing like the kind of data we can get out of an Apple Watch or out of an edge system. But these were our edge systems, and we were trying to figure out what was the functional health status of somebody living at home by themselves, and could we get that from the signal? And so old school AI expert systems, could we get signal from the noise? Got nothing, of course, right? Got my master's out of it. Fantastic. Very happy with that. And I got into how does that technology side, and these days, how does AI practically help us to do work both on the society side. But for me, it's been a sort of a thread of a passion going, these tools and computational tools can help us to do far much more. So that's what started me on my infrastructure journey. And recently, I did the trip back to the GDC conference. So I went to listen to Jensen as a learner again. So I explicitly went, hang on, I've been stuck in program management or getting my team ready for the next set of challenges, but I haven't spent a lot of self-learning time. When I'm going to conferences like this one at Theta, I'm often coming in as a presenter or as an organizer.
Sure.
And I hadn't been to a conference in a while where I was genuinely the student again. And I really, for this last one back to Silicon Valley, forced myself to did every single stand that I could in a massive stand hall. I spent hours and hours on the show floor talking to experts, relearning, because I think as practitioners, we have to get back to kind of where's the utility, what's the value, what are people selling, how are they selling it, what's the engagement points, and do I still trust myself as an expert in the field? And it was really humbling to kind of go, okay, there's a lot I'm still not getting and why these people are positioning in this way. But robotics, agentic AI, and really seeing it from the show floor in Silicon Valley, amazing experience.
So, Luke, with all the conversation that's been going on with universities and international students, has there now been a shift in optimism towards what Australia can do with research and where research is heading? And is Australia trying to pivot itself to be more prominent in that space? And what kind of outcomes might Australia be hoping to achieve? Is that sort of something that's discussed in your space?
I don't know, but I think it is. And we have strategies. There's a bit of a gap in the AI strategy space, and we might come back to that. But I think fundamentally we're optimistic in terms of Australians have always been optimistic, and especially optimistic towards how we use tech and how tech's used around us. So that adoption part as Aussies taking advantage of the latest and greatest, or contributing to the latest and greatest and being part of those ecosystems as expert users, there's no problem there. Homegrown capability at a step change in capacity or a step change in GPU availability in Australia, that's a bit of a gap at the moment.
Right.
So I think we could explore that in some of the later conversations. But in the let's go with a model of, say, why we did open science high performance computing as a kind of as a starting point. If we think about where AI's come from, it's come from supercomputing centers where we've aggregated cores, first CPU cores and then GPU cores, okay? Well, the places that did that at scale first were the big national and exascale HPC centers. The HPC centers, why did we build a HPC center? We wanted to do science at scale using computational tools. We worked with our partners back in that generation of when we were buying tin, Dell, Cray, so HP, Lenovo. Who sells us the kit? Okay, so we built from a foundation of the silicon, we started building these architectures of computer systems to get performance output quickly for what? Big scientific workloads, climate modeling or other types of models that we could put through these, let's call them research instruments at scale and at performance. And we did that, and we could compare the code that would run for the climate model in the US or in Europe or in Australia. And we wanted our capability in Australia to go, okay, does the model that we're developing, does the science work on these computers? And is the code can we replicate the code? Can we reproduce the code, whether it's run in the US system on Dell kit, run in Australia on Fuji kit, run in Europe on Bull kit or something like that. So it didn't matter what type of silicon, who was selling the silicon, but we, as a community, we agreed in that open stack kind of way, or open source community, open sharing of information and code, that we could run and trust the scientific output and trust the science behind these machines.
So a good friend of mine runs a pharma lab, and he's recently retired. That before he did retire, he said to me that they had such confidence in their modelling that if they knew that if they could scale their compute in a linear fashion, that they could achieve outcomes that they weren't able to within the time frame and the compute they had. Is it the same story with your models? Were you able to predict that if you were able to double, triple, 10x, to an order of magnitude, that you would get different outcomes? Is that something you can predict?
Yeah, so in that exascale journey, there are certainly some models that scale beautifully, and there are others where we're still trying to find the optimization patterns. But the bursting into sort of GPU land gave us a whole new set of both capability and optimism about catching back up again to Moore's law and scaling factors, and we saw that leap as we started to move into AI processors. Where I'm kind of reflecting back on this model that could be useful for us is that gap in Australia starting. We were 10x behind the best of the world in the exascale generations with the compute that we had available in Australia. We're more than 100x behind in this AI generation. In terms of the open, in the science world where I'm mostly based, in the universities, in the supercomputing labs, the amount of GPUs that we have available to retest hypothesis in a science context, we just don't have access to the kit. And so not only is there a black box problem, which we can explore, of what does it mean to both run a model in a cloud or in an LLM sort of situation of where are the black boxes in the science reproducibility question, but just the available capacity in Australia. So we were talking about aspirations and optimism. It's hard to be optimistic if I'm 100x or 1,000x behind the best in the world. And so when I'm going to the US and I'm in Silicon Valley and I'm talking to a lot of my friends in that ecosystem who are trying to do that latest and greatest stuff, there is an investment. In Taiwan, there's an investment. In Singapore, there's an investment. In countries that are GDP below Australia, there's now an investment into sovereign GPUs, science GPUs that are, and I don't want to say that Australia is not going to get there. I'm saying that at the moment, both in the strategy side and in the current roadmap investments, we're not putting, like we used to with HPC, signaling to the world that we want to be in that place.
Luke, that's really interesting. I don't think a lot of our listeners would have had that view. I certainly didn't. 100 times behind in terms of the available high-performance computing capacity.
Available for the science sector.
For the science sector, for the research sector.
Yeah.
That's incredible. What's the roadmap to correct that? I know, in industry, as a cloud provider, we're starting to see some green shoots around tenders coming out into the sector for some pretty large-scale environments and some substantial investments from some universities.
So if you're
large,
saying
do you have a view on the roadmap?
What's your definition of large? Get you out of bed in the morning to go to the supermodel, runway situation. Is it $50 million plus?
Yeah, probably the $20 to $50 million
So 20,
capital
20,
investments.
20 there'll be a few. Tens, there'll be lots. 50, okay, the NDRI strategy that we've just been allocating out is $400 million total for all the streams of very well planned, very strategic, very useful bits of the pie. $400 million pie, of which out we slice the high performance computing. Of that, we need to slice out the GPUs to do the AI work. So you have a 400 million, that's not the university spend, that's the national spend. The unis will spend on top of that and match in, and we'll grow the pie. But at the moment, in terms of what's planned and allocated from the national science budgets, not taking into account R&D credits or other ways of gaming the game or optimizing or getting co-investment in, all good things that need to happen. Just the scale is not there. We need $1 billion plus investment. We need to catch up, and we need to be optimistic about the productivity and the workforce transformation that that's going to bring into Australia. Recent things in the US, Sam Altman talking about the, I think it was Sam, saying, again, it's a transformation economy that we're building that's similar to the investments in the highway system. So you can expect that transformation will have both intended and unintended consequences, but it will have productivity benefits.
Yeah.
So we're building infrastructure that we want to be able to use for transformations. If I want to then compare or test a model, maybe the model's already been built, so I don't have to pay the cost of building the model, but I do want to test some of the truthiness of what the model's outputting.
Sure.
How does CSIRO or a university researcher who's an expert in their field test model against model or model against capacity? They're going to need some tooling, some GPUs to burn, to be doing some of that validation testing that we would expect. What's truth in that new economy?
Yeah.
If truth is filtered through our, well-designed LLMs, is it outputting? It's all probabilistic, right? So it's not going to say yes every time, but is it yes most times? And is it the right kind of yes in the right kind of patterns for us to go, oh, we trust that, so we can build public health on it?
Yeah.
I'm going to ask it some public health questions to an LLM. I need to trust that it's as trusty agentically, interoperability, output-wise, as our best researchers are.
That's right.
And so what does this, what is the implication here? So if we just take it back a step, because I think what you're saying is there needs to be a huge investment put into this space in order for us to catch up, perhaps with other nation states.
Well, just on that, just pause there for a second, because there's a couple of things that we know that's going on in the industry, right? Like I can say with reasonable authority that there is a hyperscaler in Australia that has been steadily adding 100 to 200 megawatts per data center, and next project might be 700 plus megawatts for a single data center. I'm not sure where the power is coming from for that, but that's all for inferencing, right? And there's GPUs obviously in the mix there as well. Now, maybe it's a question of cost, right? In the education sector, could they tap into a resource that would arguably be so expensive? I don't know. But within Australia, there's that kind of spend going on.
Well, that was leading me to, I think we're both going to the same place. Yeah. Why can't, and I'm sure you got a good answer for this, Luke, but why can't people just consume this stuff on tap, consume GPUs from a hyperscaler, either onshore or offshore, to do this work? So go where the investment's already been made. Apparently the hyperscalers have deep pockets for this.
We don't always have to own it to run it or to get the utility value out of it. I think that's fair. You might think again about road models. How do we build a public road? A public-private partnership's okay to build public infrastructures. We've wrestled that up in the public debate, right? So there are models that have worked to leverage finance to get us the infrastructures so that we get the productivity. I'm not so much fussed about the building of it. We know how to build. The market can solve aspects of those problems. but who owns the job that runs and who helps us pay for that? So it's $1 billion capex to build the thing, but it's X amount per year to run a thing. I want access to the run part to do the science.
Sure.
If I've got confidence that the data is sovereign Australian data residing in Australia,
Yes.
that some of the signal value, not just the utility value of crunching the numbers on those data are in Australia, but that or in a cloud globally, to that matter. But the signal that comes out of that, the feeds of the agents that are going to run on those systems, there's value in that as well for us. And then there's can I compare A versus B, and am I getting a subsidy for the research grant or for the research activity to run it on that kind of compute? So I don't need to have the kit built and owned by, say, CSIRO or by a university. We need to be able to run those cores, but we need some assurances from, is the value staying in Australia? Is a lot of that value staying in Australia? Is the information that I'm giving up valuable? And how are we monetizing that in Australia? Is the scientific output going to be valuable for Australia? Is the industry partnerships going to be valuable? That's the macro ecosystem that we're talking about. The delivery of who owns the compute's a very small part of that broad ecosystem.
Just for our listeners, you mentioned sovereign. Why is that important?
We have rules and obligations about and contracts about what we work with, how we work with it. And we also have aspirations as a country. We have aspirations that are distinctly Australian for the type of community that we want to build here in Australia. The computational agentic AI that we build should reflect those Australian characteristics and assumptions and values and judgments, and be generating value for Australian productivity moving forward and Australian tax benefits. And if we're thinking about growing a country capacity-wise, we're thinking about the workforce, we're thinking about the workloads and where the work gets run. And then in computational and data terms, I think then we have an obligation about that. What's our contribution and the value that are going to be retained in Australia for us to stay as a prosperous global economy with a way of living and a style of ways of working and a healthcare system that we value those things.
Yep.
So having the data in Australia to Australian terms and conditions, maybe we can achieve that wherever it is. I don't mean sovereign just by we have to lock it up in a vault in Canberra.
Data capacity, I get it. Yeah.
Right. So by rules and by legislation and by probity, also what I'm doing to my data and who else can do things to it is important to me as an Australian.
Yeah.
And so the value that then and the trust that I put into these systems not being on-sold to other partners without my say-so as an Australian citizen, and where the additional value, the marginal values and the additional contributions that the macro parts of those data then have at scale, as we know from AI patterns, okay, we've put all of those into these systems. Who monetizes that? I want that Australian value to come back to Australian citizens in the long run.
Yeah.
And so when I'm saying sovereign, I don't just mean from a rules protection legislative perspective. I think that's important, but I'm talking about the full economic value of us building a value chain for Australian industries to co-invest in.
Yeah.
So if we've got really good bulk data from having done mining at scale, what's the long-term value of that? Maybe we've extracted the value from the ground, but those data might continue to have ongoing value as we're taking more challenges with our company partners to say we need to go to more extreme mining techniques. So say we've got a great Rio Tinto, great BHP, we're here in WA. So their skills and capabilities to extract iron ore in an efficient way at global scale is unparalleled, right?
Yes.
Let's make that assumption. Say suddenly we get into asteroid mining. Who's got the best trained models and the best national sovereign capability to go asteroid mining.
Nice.
Right. It's like, okay, and where have we built that sovereign capability, and where does that value retain?
Yep.
And where's the workforce and where's the capability that could leverage the whole IP food chain that we've built through models and agentic capabilities, robots that we've sent out into the Pilbara,
Yeah.
and how do we repurpose those? That's the sovereign value that I'm talking about, retained for Australian.
Is there, acknowledging the intent and purpose of AeRO, is there a healthy competition within universities to create the best possible climate for researchers?
We're the best frenemies in the world.
Okay, how does that work? How do you balance that? If every university is trying to attract researchers, how does that work?
Well, the race for talent, but the race for credible talent that then wants to share that information and is passionate about their field. That's the kind of ecosystem that we've built up in the world's best universities. Australia's a great provider of the world's best universities. Our research outputs, our research practitioners, our research infrastructure is genuinely world-class. So if you think about our group of 8 universities, the top research universities and our peer friends in the sector, it's a great place to do research work with partners. And so that healthy competition of going after research grants or collaborating on research grants or strategically saying, you're really good at these areas, we're really good at renewables and materials tech at UNSW, come to UNSW to do some research into batteries or renewables or material, biggest and best engineering school in Australia, come on down. One of the best mining schools in Australia. If we want to do research, we have to give places where researchers with the style of practice, these both short-term and long-term projects that they want to get their teeth into with industry input, valuable, what we call translational impact, real value impact back down. So in medicine, we want people to live longer, people to have less disease. In mining, we want to be more efficient. We want to have translational impact to our economy, to our people, to our sovereign capabilities. And so the university sector contributes to that. Now, we don't mind then if one of our researchers is a rock star and wants to go off and have an IP and found a company. That's now totally possible within our ecosystem. But you can't just have one or two. You need to have an ecosystem where there's enough competition at scale. And I think that's what we have in Australia, and we're in a really good spot.
Really interesting stuff there. A takeaway that I just got from that was, and it's a nice soundbite, once we've finished digging stuff out of the ground, we've got all of this other value that we can retain and an understanding of the future and what that might look like for Australian industry. I think that there's so much scope there, to use your words, to be optimistic about.
So where did we get version 1 of the LLMs from?
Oh, what a great question.
Where did it come from?
That's a loaded question. I want to believe it's somewhere in Australia.
We stole it.
Okay.
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 The web, we put stuff out on the web and the web got scraped.
Yep.
And we trained our
All of that
LLMs
data. Yep.
on basically everything that the spider robots or that ethical and unethical practices pop the lid on various sources of trawlable content on the internet. Now, the universities and DARPA and everybody helped to contribute to the web, and a lot of us put posts up on Reddit, whether they were good posts or bad posts, they all got read. And we trained the LLMs on research output of value, research output of potentially negligible value. We trained it on Reddit, we trained it on the whole corpus of the web.
All right, I'm going to ask you a question. How close are we to general intelligence? Question number 1. Question number 2. Actually, let's just start with question number 1. See where it goes.
Let me finish just my thought of
Please.
Version 2 of the LLM value, just finishing off on this thought towards asteroid mining robots. Is a university sector, is our commercial sector, is the web going to exist in next week, next month, next year? Is the information value that we're generating now through AI just making the web dumber because it's trained on the current content of the web. And the people with the information, research groups, companies, are they putting it out on the public web to be retrawled by the next version of agents? And finishing off that sovereign conversation, company data, valuable IP, valuable monetizable content that's going to train the next generation of LLMs or agents to do truth telling against. How do we monetize, and are we going to give it up for free by putting it out in what we call the open science web?
I like this. You and I have spoken about this, right? The value of quality data to train LLMs. We have spoken about this.
I think, yeah, our concept was...
There's a market in this, isn't there?
Of data as the raw material for an AI factory and an insight. And all of a sudden, organizations everywhere are finding that data that had little to no value before now is incredibly valuable.
So if you're reading the GIS data that Geoscience Australia has pushed out, why don't you give them a click rate?
Right.
Like a click charge on that compute cycle
100%.
So that we can repay and so we can do the next gen.
Yeah.
I'm doing, really good, life science work, and say we put out a new trusted model. Why can't I get, as a university or my researcher or a mini company that we spin out, where's the value chain to feed back in? Or do we keep it because the actual protecting of it's more important for us, and we'll use the open models to test against our private? So I'm imagining now that takes us. Will we know when AGI has happened? Will OpenAI tell us?
Well, so we had Stephen Worrell on the podcast, right? And I put him to the question, because between the contract of Microsoft and OpenAI, should they achieve it, everything stops. And the definition exists within those contract artifacts to which no one's allowed to know about it. I asked Stephen about it. He wouldn't say a word. Will we know about it? Almost certainly not.
Again, why should we have publicly available, and I mean for research publicly available, in the sense of creating common good for common problems at global scale, if you allow that type of development to happen by a private company, totally cool. They've invested shareholder money to go into that. Where's the country? Where are the countries' efforts to create AGI at the moment? If it's that level of important, where are the public open models heading towards in the AGI conversation? Does it become a privately held shareholder tool? That's an interesting model. And if it's done by a private company to private company rules, now here we're going totally metaphysical.
Let's go.
But then you end up, if an agent is basically prototyped on a human and AGI is closer to a human, and a company creates a human, I call that a slave. If a government creates that activity, we know as governments, we know as communities what we do with humans. And we treat humans differently in the public sector than we do in the private sector. So I apply a mental model of, it's great that all this investment into AGI and AI is happening because we're getting genuine benefits. And Sam speaks about this eloquently, that there's a whole lot of passionate people wanting to do genuinely scientific good through these company infrastructure patterns. No disrespect meant at all. That is wonderful work by wonderful, smart people happening that is genuinely going to benefit humanity, probably. I'd also want some of this to be happening out in the public, under public scrutiny, with public visibility over these kinds of capabilities. And if we generated AGI in the public, what would that mean as a public creation versus a private creation?
Excellent.
Really interesting. Luke, this has been a fantastic conversation. I'd love to ask you one more question to finish off our chat today. For people listening who might be questioning the value of some of this technology and where it's all headed, and perhaps a little bit fearful of the unknown, I think we're at the precipice of, a new era in terms of technological capability for humanity. I guess I take from this conversation you take a more optimistic view of where this technology can take us. What would you say to people who are a bit unsure or a bit fearful of where all this is going?
Humans build. Humans build tools to build. We've built amazing things with tools. We'll keep building amazing things with tools. Tools and then infrastructure transforms societies. Healthy running water in a city stops disease, stops people dying, people live longer. Building roads to get us from A to B faster enables us to do commerce and trade more effectively. Stuff that's efficient to do over there can come over here quickly. Digitally, we know the transformations that have happened digitally, the friction freeness that I don't have to line up at a counter at my bank to do 99% of my banking work is now doable in my pocket. That has saved humanity countless productivity hours. I have a research assistant in my pocket with ChatGPT. The desire of the researcher has always been to have a team of researchers working with them at speed, at PhD level quality, and we've always loved, for good or evil, yelling at our young students to produce output so that we could move faster.
Certainly.
I have 20 PhD students in my pocket right now with ChatGPT, ready to do my bidding, to do little micro pieces of work that we can start pulling together.
Incredible.
What I'm hearing from you is that our aspiration will always be greater than the gains that we get from the technology. that we
Massively.
build.
I want to do this kind of stuff that we're doing and transform a couple of other planets. In the, like, Elon's got that Mars thing. Why stop at Mars? Yeah, we need these massive goals that humanity's always had at scale. I'm not scared about the agentic or AI or AGI future. I'm excited by it.
You know what? It's a happy place to be because it's going to happen anyway. We're all on this path. It's been amazing talking to you. Really
Pleasure being
appreciate
here.
it. On set, here we are. Theta, Jono,
Really insightful. Thanks so much for joining us.
thank you
Luke.
so much, Luke. Appreciate it.